All right, so on Friday, you did the definitions for chapter 4, and we're going to start the chapter today on page 238, and we're going to be working with and classifying triangles. I am not going to go over all the definitions that you did on Friday. That's what the assignment, the electronic assignment was for. So we're just going to go ahead and get started with example 2, where you are asked to classify triangle PQR. And here's triangle PQR. Five degrees, 45 and 59. Day 31. All right, so classify triangle PQR as acute, equal, angular, obtuse, or right. Explain your reasoning. So here's the triangle we're looking at. We're looking at this big triangle around the outside. PQR. Does everybody see it? What you have to do for angle 2 up here, or I'm sorry, angle Q, is you have to combine these two angle measures right here. All right? Because the sum of those two angles makes up this entire angle Q. So what's 45 and 59? 104 degrees. So this angle Q, measure of angle Q up here, is equal to 104 degrees. All right, these two combined. So if we're classifying triangle PQR, it's got one obtuse angle, doesn't it? So it's classified as a is obtuse. While we're here, let's continue with this classify triangle PQR. Let's classify triangle PQS. All right, we got triangle PQS, this smaller triangle on the left-hand side of the big shape. All right, if we look at this 90-degree symbol down here at angle QSR, if the right side of this angle is 90 degrees, what's the measure of the left side over here? Yeah, it's 90 as well. These two are a linear pair. They sum 180, and if this angle is 90 degrees on the right, then the angle on the left is 90 degrees. So look, we got triangle PQS. It is a right triangle. And do you notice anything else about it? It has two angles that are 45 degrees. So if a triangle has two angles that are congruent, then the sides opposite those angles are also congruent. That means that this side right here, QS, is congruent to side SP. So that makes this smaller triangle in here also isosceles. All right, it's a right triangle because it's got a 90-degree angle. It's an isosceles triangle because it has two congruent sides. And then let's classify triangle QSR while we're here.
Sorry.
So that's the triangle over here on the right. QSR. It's got one right angle. So that makes it a right triangle. Now, by its side lengths, if none of the angles in the triangle are congruent to each other, then none of the side lengths are congruent to each other. So a triangle with no congruent sides is called scalene. All right, and that was part of your definitions from the other day. So we classified the three triangles in that diagram right there. Any questions on any of that? Okay. So then let's look at example 4. On the top of page 239. If M is the midpoint of JL, classify JKM. And explain your reasoning. So here's the triangle that you're given. We've got a 0.75. Here's vertex J, K, M and L. Side KL is 1.3. And this side is congruent to this side. What else we got going on here? All of this is 1.5. And M is the midpoint. All right, so if M is the midpoint, isn't M to L the same distance as M to J? All right, and wouldn't that be half of 1.5? And half of 1.5 is 0.75 and a 0.75. Now, see the tick marks? Had a tick mark here and a tick mark here. KM is congruent to ML. If KM is congruent to ML, and they're both 0.75, then that makes K to M 0.75. So if we're classifying triangle JKM, it's got three congruent sides, doesn't it? That's called equiangular. Congruent sides is lateral. Congruent sides equilateral. But if all the sides of a triangle are congruent, then all the angles in the triangle are congruent. So these three angles are equal to each other. So that makes the triangle equilateral and equiangular. Now, another thing that you need to know and understand is that the angles in a triangle sum 180. The three angles in a triangle sum 180. So if these three angles add up to 180, but they're all the same, then aren't they 60 degrees each? Because 180 divided by 3 is 60. So not only are these angles all congruent, but they all measure 60 degrees. Let's classify triangle KML while we're here. KML. Starting up here at K, going down here to M, and then out to L. It's got two congruent sides, doesn't it? And a triangle with two congruent sides is called isosceles. All right, so any questions there? Let's look at example 5, finding missing values. And we're going to find the measures of the sides of isosceles triangle ABC. And here we go. Vertices A, B, and C. Side AB is 9x minus 1. Side AC is 4x plus 1. And side CB is 5x minus 0.5. All right, you're told that the triangle is isosceles, and the tick mark side AC is congruent to side BC. So if you're told those two sides are congruent, and they are both represented by expressions, well then let's set the expressions equal to each other. So 4x plus 1 is equal to 5x minus 0.5. So we're going to subtract 4x from each side. And 1 is equal to x minus 0.5. And then we can add 0.5 to each side. And 1.5 is equal to x. So now if we know that x is equal to 1.5, then side AC is equal to 4 times 1.5 plus 1. And 4 times 1.5 is 6, plus 1 is 7. Side BC, now this is, side BC should be 7, right? Because they're congruent to each other. But let's double check the math. 5 times 1.5 minus 0.5. And 5 times 1.5 is 7.5. Minus 0.5 is 7. So the algebra is correct. Your value of x is correct. And then side AB is equal to 9 times 1.5 minus 1. So 9 times 1.5 is 13.5 minus 1 is 12.5. Any questions there? All right, so let's do one more example, bottom of page 239. Now they give you a triangle. Find the measure of the sides of equilateral triangle. Find the measures of the sides of equilateral triangle FGH. And you're given this triangle. Any volunteers want to tell me what equilateral means? Yes, ma'am. 3 congruent sides. Thank you. So you take this triangle and you add your tick marks. All the sides are the same. So all the expressions for the sides are equal to each other. FG is 2y plus 5. G to H is 3y minus 3. And F to H is 5y minus 19. Now, you can pick any two expressions and set them equal to each other, right? And then substitute for y. So I'm going to take 2y plus 5 and set it equal to 3y minus 3. So subtract 2y from each side. 5 is equal to y minus 3, and add 3 to each side. So we get an 8 that's equal to y. So we'll do FG first. FG equals 2 times 8 plus 5. 16 plus 5 is 21. GH is equal to 3 times 8 minus 3. 3 times 8 is 24, minus 3 is 21. And look, if the y value of 8 made the first two sides congruent to each other like they're supposed to be, don't you know that the value of y is correct? And you don't have to check it for the third side. What's FH going to be equal to? 21. Good. All right. So any questions on finding side lengths and classifying triangles today? All right, then your assignment for today is going to be on page 240. Problems 4 through 13. Problems 4 through 13, and then I want you to do 36 and 37. Over on the next page. All right. This is the second assignment of term 2. Please make sure that you are checking your odd answers in the back of the book as you're working the problems.